Sathyabama Institute of Science and Technology.
Happy to welcome you all Sathyabama video lecture series. Today I am going to discuss about computer graphics and multimedia applications in this line drawing algorithms. So in computer graphics, first step is like for drawing any object, we need to find the how to draw the lines. So this is the initial step for drawing the object. So for this we are going for line drawing algorithm. So in this topic we are going to see two algorithms, that is DDA, Digital Differential Analyzer algorithm, Bresenham's line drawing algorithm. So these two algorithms we are going to see in detail how to solve the line drawing by using these two algorithms. If we want to draw one line, we need two endpoints. So we can give two endpoints. In between, what are the points we have to find out for complete the particular line. So this is the first step we have to find out. So here this is the algorithm first equations, y equal to mx plus c. So x and y is the coordinate is given, c is the intersection point, m is the slope of the particular line, right? So here, so in this DDA first algorithm, it's a scan conversion line drawing algorithm we are seeing. So for this algorithm, we have to take unit intervals between starting point and ending point. So each and every unit intervals point we have to find out, then we have to complete the particular line. So we have to find out nearest coordinates. So here, so first you have to get two inputs, that is first starting point and ending point. That is the first input values we are getting. So first step we have to find out the difference between the coordinate dx. So that will be assigned as a step value. So you have to check dx and dy. So the differential value of x1 and y2, x2, y1 and y2. So we have to check whether dx is greater than dy or not. If it is greater than, that value will be assigned as the steps. See, for example, if dx value is greater than dy means we have to assign the steps as a dx value. Otherwise dy will be the steps value, right? So each and every step we have to calculate for each and every x and y coordinate system. So here this is the simplest line drawing algorithm. So here we are giving all the ending points one by one, right? So this is the given steps. So first starting coordinate xa, ya is given, ending point xb, yb is given, as I told you. This is the two input we are getting from the user. So this is a step 1. So in step 1, what we have to calculate? Dx. Dx is the xb minus xa, that is a differential value of x coordinate. Same like y also we have to calculate, that is yb minus ya. So next slope. So each line we have to calculate the slope. So the slope we are calculating by using the formula dy divided by dx. So this is the first initial step we are calculating. So next step we have to find out absolute value of dx and absolute value of dy. So if absolute value of dx is greater than absolute value of dy means the steps value will be the absolute value of dx. So if dy is greater than absolute value of dx means we have to assign steps will be the absolute value of dy. Absolute meaning in the sense we have to avoid the negative sign, right? That will be assigned as a steps. So next we have to calculate each and every x and y coordinate increment value. So by using this formula, that is dx divided by steps, y increment means dy divided by steps. So each dx and dy value we know, we calculated already, dx x2 minus x1, dy y2 minus y1, steps we calculated. So we are just substituting in the formula, we are getting x increment value and y increment value. So in step 4, so each and every conditions we have to check. So x value we calculated, y value calculated. So each coordinate values we have to increment. So here we are having three choices, that is m is less than 1, greater than 1 or equal to 1. So in these three cases, so if case 1, if m is less than 1 means x value will be incremented by plus 1. So y value will be incremented by yk plus 1 equal to yk plus m, that is slope. In case 2, m is greater than 1 means y value will be incremented by 1, x value will be incremented by xk plus 1 by m. In the other case, case 3, if slope will be equal to 1 means x value incremented 1, y value also incremented by 1. So these are the three different cases we have to consider. So next step 5, so we have to repeat the step 4 till the end of the points will be reached, right? So that is the equal point. See, this is the algorithm what we told now. So each and every step we are writing in the algorithm wise. So first step we are getting all the inputs. So we are assigning all the variables. The first step we are calculating absolute value of dx is greater than absolute value of dy. Which is the greater, that value will be assigned as a steps value. So we are calculating x increment and y increment. So by using dx divided by steps, y increment will be dy divided by steps. The loop will be repeated till less than number of steps. That's we have to maintain. So k equal to 0 to k less than steps, means 0 to less than steps the loop will be going to repeat by incrementing each coordinate value, x and y coordinate value. So here, so whatever value you are getting, that will be assigning as a xi y pixel. So we see the example for this. See, for in this case we are getting two input xa ya xb yy, that is starting point and ending point. 5 comma 4 is my starting and coordinate value, line starting point, ending point will be 12 comma 7. So it's given. So first step dx and dy we calculated, then we are calculating steps value, whether dx is greater than dy. If it is greater than, that value will be assigned as the steps. So x increment we are calculating, y increment we are calculating. So by using the formula dx divided by steps, we can calculate x increment. By using y increment, dy divided by steps, so we can calculate the y increment value. So the loop will be repeated till number of less than steps. So 0 to less than steps. If I am having 5 steps, means 0 to 4 the loop will be repeated. So repeated, the value whatever we are getting, that will be assigning as the pixel value. See in this example, so we are starting from 0 to 6, because here we are getting 7, so steps will be 7. So 0 to 6 times the loop will be repeated. We are getting x and y coordinate value. So what are the value we are getting, that will be assigned as a set pixel value, that we have to plot in the graph. So in DDA algorithm, the line will be like zigzag, so some accuracy will be less. So for this we are going for next algorithm, Bresenham's line drawing algorithm. So in this algorithm, there is a name itself, who is the invented. So this algorithm is used for scan converting a line. It was developed by Bresenham, as I told you. So it's an efficient method. Here we are using addition, subtraction, multiplication operations. So each operation will be generated and it will give the little more smooth line compared to DDA algorithm. So this is my steps for Bresenham's line drawing algorithm. So same thing here also, starting point, ending point, we will get input from the user. So we have to determine which point we are using as a starting and which will be using as the end. So this is the calculation part. If the first xa is greater than xb, means the x end will be the xa value, otherwise xb will be the end value. So here the same thing, the loop will be repeated till delta x times. So we will see the example, it will be clear more. So here the p value, p plus plus, how you are incrementing. So the next pixel value will be add with the 2d value, then next value will be allocated by 2 dy dx value. See, this is the example. Here I am getting two input 20 comma 10, 30 comma 18. This is my starting point and ending point. So here the solution, first step dx we have to calculate. So next dy we have to calculate, that is x2 minus x1, y2 minus y we calculated. Then p value we calculated by using the formula which is given in your algorithm, 2 into dy minus dx. So just you substitute the value, we are getting p value. Then 2 dy is one variable, 2 dy dx is another variable. So according to the condition, these two calculation part we are calculated, because in this we know all the dy dx value. We just substitute the value, we are getting this 2 dy and 2 dy dx value. See, say we are checking the condition, the first value is greater than 30, the loop will be repeated delta x times, I already told you. So the each and every value we are checking the condition. If the condition is satisfied, the p value just we are substituting p value equal to x6 minus 4, that we are getting, that whatever value you are getting according to the condition, that value will be assigned as the set pixel value. Here in this case we are getting 21 comma 11. So the loop will be repeated till delta x times. See the example, see the table, it will be clear more. See here, I am getting 0 to delta x times. Here in this example, I got delta x as 10. So 0 to 9 times the loop will be going to repeat. So pk value means each value we calculated, p0 we calculated, 6 we got it. So x value will incremented by 1, y value will be incremented by 1. That's why 21, 11 we got it. So the loop will be repeated. If you are getting positive value, pk is positive value, the each x value and y value will be incremented by 1. So 21 will become 22, 11 will become 12. So next k equal to 2 condition, we are getting pk value minus 2. If we are getting negative sign, x value will be incremented, y value will be as it is. That's why in this case we are getting 22 will be incremented by 1, that is 23 we are getting, then 12 as it is. So the loop, this is the only case we should remember while doing the Bresenham's line drawing algorithm. So here the same thing we are calculating according to the formula pk plus 1 we are calculating till the delta x times. So in this case delta x we are calculated in this example 10. That's why if we are starting from 0, so 0 to 9. So the loop will be repeated 0 to 9. One more thing, last end point will be, we have to get the starting point and ending point we have to get. In between set pixel points we calculated, we just draw the line. See the line how we are getting. So compared to DDA, in Bresenham DDA it will be more zigzag. Here little bit zigzag, but line it will be little more smooth. So both the algorithm having both advantages and disadvantages. So here in DDA, so accumulations of round off errors, because we are doing the floating point additions, we are rounding off the fractional value. That's why we are getting some the point exact calculation is missing. That's why main disadvantages in DDA algorithm. So in Bresenham's line drawing algorithm, it's a fast and incremental algorithm. So it uses only integer calculation part. So here in this Bresenham's algorithm, you are going for scan conversion algorithm. It's a very fast, a little bit speed. Then as integer calculation only allowed, both addition and subtraction, but bits shifting also. So compared to the DDA, the Bresenham's algorithm, the line we are getting as in between the pixel value little more smooth. So we are going for this Bresenham's line drawing algorithm. So here advantages of Bresenham algorithm, it's easy to implement and it's a fast and incremental algorithm, little faster than the DDA. It uses the fixer point only. So here also some disadvantages is there. So though it's improving accuracy compared to DDA, little more, that graph itself we can see little bend was there. So little more accuracy is reduced. So little more improvement need for conversing the algorithm. So these are the two line drawing algorithm we are using in the computer graphics and multimedia. Thank you.